Okay, welcome back to the third video for the 6th and 7th grade computer science professional development. If you've watched the first two, you've kind of gotten a good basics for understanding on how to use the Autodesk Tinkercad system for Arduino simulation. If you noticed, we're back ready for task 2. We're going to be looking at the serial monitor and variables. And if you look at my account where I'm sitting at, you can see my last two. If I wanted to go back, I could click into them, tinker this, keep making edits. Where we've done before is I've taken you up to the search and we've gone and looked for my templates. In this case, the template there is a template available and you can go find that. But what I would like to walk you through is how to actually create a new circuit. So we're going to go ahead and click that. And where it's going to take you is just kind of this blank screen. And you're going to have a couple options. It just puts in this really random name. I generally, I'm going to name it something more relevant. Task 2 is what I'm doing. It's better than cool Elmsing or whatever it was. So what I'm going to do, this one's going to be actually really simple in terms of the circuits that I need. I need an Arduino. So I'm going to control it, click it. Sometimes it takes a little time because it's a bit of a larger component to pull out. And I like looking at them like this. You don't have to rotate it. That's just how I got used to working with a physical Arduino, was always in its vertical position. And it makes it really easy to read all the numbers. And for this case, I'm done. I won't need anything else to be pulled out of the components. You can look and find there's a whole bunch of other stuff if you wanted to pull out things. But what we're working on here, I just need an Arduino. So I'm going to pull out my code. And when you create a circuit from scratch, what it's actually going to default to is block-based coding. And in my opinion, having worked with students of a variety of ages on programming, is middle school and up is too old. They don't need blocks. They should be and can be working with text. Obviously, if you're working with the real Arduino Uno and the Arduino IDE, you don't get blocks. You have to work in text. If you're working in Tinkercad, you technically have the option to work in blocks. I highly recommend against it. It is going to be so much more beneficial for students to work in text, especially going forward. They are absolutely capable. I've worked with students as young as 8 in text-based programming. They can do it. It just sometimes you have to kind of watch them, and it takes a little bit more to get started, but once they do, they shouldn't have any issues. And what it does, like we talked about in the very first video, task 0, it tends to default to the hello world of Arduinos. It's blinking an LED. If I in fact ran this right now, you would see this is called our onboard LED. It's tied in with pin 13. If pin 13 is high, this onboard is high, and that's what it's doing. I don't want any of this, so I'm just going to delete it. My template, what it would have taken you back to, is exactly this here. You notice it's a little different. They've got void set up and then the open curly bracket on a different line. It's all the same. It does not matter. My personal preference is to have it up top. That's just me. It does not matter at all. It's just how I like looking at programs. So I'm going to set it up that way. Computer, again, white space. Doesn't know, doesn't care. That's all for me. What we're going to be looking at here is the serial monitor, which is something super important that we can use, helpful sometimes for debugging if you are too lazy to use a real debugging program, which is most people in all levels of computer science and people working in programming. It's also important if we just want to send messages or get some information sent back between the computer and the Arduino, or in this case, my make-believe computer and my make-believe Arduino. To start, why is it even a serial monitor and what's serial communication? So I'm going to ask, what does USB stand for? And I say, use whatever you need to. Most people hop onto Google. I know what it is. In fact, it is a universal serial bus. So the fact that we're plugged in, if you were using a real Arduino, to a computer through a USB port, I'm using serial communication. It's how the Arduino and the computer are talking. Or fake talking, in the case of Tinkercad. So at the very bottom here, you're going to see this button that says serial monitor. On the real Arduino IDE, it is in a little bit of a different location. I'll make sure I have a quick little video kind of showing where all the fun stuff there is. But for here, we're going to keep moving on in the Tinkercad version. I can resize it just like I can do the code window. I pull it up a little bit, but I don't need tons of it. It's right there. If I ever want to make it go away, I just click serial monitor again. It's going to pop it back up. We'll talk about the clear button in a little bit. How am I going to use it? there's going to be a couple things. First thing, in my setup, I've got this code here. Welcome to copy and paste it, or just type it in. We need to tell it to start. So I'm going to use serial.begin, and I can use a parenthesis. And what we talked about before, capitalization is incredibly important. Note that serial does start with a capital S. Begin is a lowercase b, and there is a dot between those two words. And I'm going to put in a number. In this case, this number is 1000. If you're working on a real Arduino using the Arduino IDE, you're probably going to use a number that is much higher, like 9600. Because a real computer and a real Arduino can communicate a lot faster than a simulation. The simulation is emulating this communication. It's not going to be able to communicate that fast. This is the baud rate, and what that means is how many times a second are we communicating between the computer and the Arduino. A simulation cannot keep up with 9600 little bits of information being sent back and forth a second. So we go way lower. This is also going to be something you might need to adjust based on your computer and internet speed. It might even be your internet speed of the day. I've had to go as low as 100. Generally, 1000's been stable for me. Your mileage will vary. What you'll see is when you tell your program to start simulation, you're going to see a simulator time. And if this is not ticking at about 1 second per 1 real second time, you're going to want to change your number, because that means the simulation is slowing down and it cannot keep up in real time. There'll be times where if it's trying to run too fast and do too much, you will actually start seeing it'll be like, it'll have your hours, minutes, seconds, and then a decimal with fractions of a second. That's when you know you're probably trying to do too much and it's really slowing down. But again, for now, 1000's a good starting point. You see what you can do. Let's add a simple message. We're going to start in the setup section of the code. I'm going to add the following code beneath serial.begin, because obviously I can't do anything with serial.begin until I have begun. So I must do that first. And I'm going to do my very traditional computer science beginning. Serial.println. And if you break it out. So serial is type of communication. Print line. There's also one that's just print. It does not have the LN. That is an L, not an I, or anything crazy like that. And I'm going to put a apostrophe, hello world, exclamation point, and apostrophe, and parenthesis, and a semicolon. Because once again, semicolons are the law. I'm going to run my program. Well, what happened? Hello world happened. Happened once, and that's it. My program is still running because we hit the void loop section. There's nothing there, but it's still running. So if I want it to end, I just gotta end it manually. It's shown up on my serial monitor. Then what I can do, I've got this cool clear button. It will erase anything that has happened so far. Now, if I were to try and do this without quotes, bad things will happen, because it's gonna be like, what are you trying to do? Hello was not declared in the scope. It's treating hello like a variable, which we haven't even quite got to yet. If you're looking close, we'll get to those in a little bit. What we need is the apostrophes, and what that means is what's contained in it is called a string. It means, hey, this is a group of stuff. That's just like words and things. The computer's like, I'm just going to put all these little characters in the same order. I don't know what they are. I don't know what they mean. And I'm just going to send them out to the serial monitor and let the user figure it out. Well, what we want to do is we want to experiment a little. So I'm going to take this out of the setup section, drop it in the loop section, and then start my simulation. And if you'll notice, I've got hello world happening a lot. And it's still happening. And it's happening forever. Because it is going to happen forever. Because it's in our loop section. This section runs forever. And now, back to what I was talking about, the baud rate. If you're noticing, this is not at all running close to real time. It's been longer than 8 seconds since I hit the simulation button. So what I'm going to do is, I'm going to go ahead and slow this down to about half. It really just has a lot to do with your internet speed, your computer speed. You'll notice when I stopped and restarted, I interrupted it in the middle of the word hello world and then started a new one. So you do not have to clear the serial monitor every time between running the program. It won't stop it. But also sometimes you'll get some weird stuff like this, which later on, it makes it a lot clearer if you remember to clear. Now, my simulation was still running quite slow, but I'm okay right now with my current baud rate because I'm not going to be doing too much that requires it to run continuously or looping, and it's still running fast enough for me. Your mileage, again, may vary. So what was happening when I was in the setup section, it printed hello world once. In this section, it prints it a lot in the loop. Forever, in fact. Next thing we want to do, this is why we're really in the serial monitor right now, is because we need to learn about variables and what that means in terms of computer science versus what it means in math. But we're going to start talking about math. So there are a couple types of numbers. Off the top of my head, we've got real numbers, whole numbers, integers, rational numbers, irrational numbers, so on and so forth. There are a whole bunch of types of numbers out there. What we're going to care about, we want to look at integers and decimal type numbers. So we'll have students do like, okay, well, which even are these? Do we know what the difference between an integer number and a decimal number is? Well, in fact, the first one are integers, and these are decimals. That's going to be a huge difference. So in the Arduino, we can do a lot of really complex things. The Arduino, not so smart. We're using numbers. You got to tell it what type of number you're doing. It's not quite like a programming language like JavaScript where you just say, hey, this is a variable, computer, you figure out what we're supposed to do with it. You do have to tell it whether or not the number you are using is an integer or a decimal. And that is just something we have to do. So when we're going to tell it, we're going to use these two words, int and double, and we'll explain more of that as we continue on downward. We're going to work primarily with integers, very little with doubles at all. But first, just like in math, we use them to store unknown quantities. In programming, we're going to store some data. It's a box. I can put things in it. I can put a number in it. I can also put a string in it. So, for example, I'm going to go ahead and move this back up here. Fix my indentation. I'm going to say that, actually, let's just keep going. I'm going to change my mind. I know I'm crazy. We're going to explore these variables a little bit. What I've got in the setup section, we're going to add code to create an integer type variable named x. Not the best variable name, but for right now, I'm not doing anything complicated, so I'm not going to come up with anything like super clever for a variable name. It's a variable. I'm going to start with int, int for integer. And then its name. I'm going to say, hey, you're equal to, assigned to, 3. And then a semicolon, because once again, it's the law. And on the next line, we're going to create another integer type variable named y equal to 4. And it should look just like the line before. Again, I've given a little less instruction. Hopefully you can figure it out from kind of context and like, hey, we just did this from example. I want one that's y. It's going to be equal to 4. And then what we're going to do on the last line, we're going to create another integer type variable named z. So I can get that far, int z. And we're going to set it equal to x plus y. So the code, giving it to you, is x plus y. Quite literally, x plus y. And from there, I'm going to place a print command in the setup section. I'm going to display the value of z. So I'm going to get rid of my string hello world. I don't want it anymore. And I'm going to just put in z. Now, if I were to put it in apostrophes like hello world was and run it, when it does, I'm going to literally get the output z. That's z, the string. Anything inside of apostrophes is a string. It is not the variable. So what I'm going to do, if you look and it says, here's the code exactly. There are no apostrophes. I'm going to take those right back out. When I print it, z, hopefully we all know, x plus y, 3 plus 4, 7. Hopefully the computer tells me 7. It does. I didn't clear my serial monitor, so I still have that old z. Again, let's just kind of keep track of what you were doing. Or clear it every time. Doesn't matter each. But just know it's not doing both. That's what was there before. Because if I ran it again, I'll have another 7. And another 7. So on and so forth. What value is displayed? It's a 7. Is it what I expected? Yes, it is what I expected. Because 3 plus 4 is 7. And then let's just do some really basic math. Just to see if it makes some sense. There's a whole table. Right now, I'm going to hit the important ones. I'm not going to run through every single one of these. Once you get the basic idea, you can kind of figure that out. think in terms of this video, that'd be something most of you end up fast forwarding through. 3, 4. Okay, let's see. I'm going to do it the first example. So 3 plus 4. If I do the z onto the plus, it was 7 under minus. Okay, cool. Let's replace minus. Start simulation. It's -1. That checks out. That makes sense to me. I'm going to go ahead and clear this. Remember to keep doing that. I'm going to use stop my simulation. I got to go multiplication, which in this case, of course, we use x as a variable. Letter x is, you know, the letter. It's a variable. It's not for multiplication like most computer programs, like Excel or any other programming language. Asterisk is your multiplication tool. So we're going to simulate that. Hey, 3 times 4 is 12. Fantastic. That still makes sense to me. And then division, obviously we don't have that on a keyboard, but we do have a fraction bar, /. That's for division. Clear that so we can all see it. That is 0. That is not what math tells me that should be. We'll have to explore that some more. I'm going to write that down. Interesting thing, though. Because most of us know if we divide 3 by 4, that's going to be 0.75. It's not 0. Arduino's telling me it's 0. I'm going to write it down. I'll keep going. See what happens. Next thing I'm going to do for this line, x and y, it wants me to flip 4 and 3. So it wants to switch the values. So x is going to be 4. Y is going to be 3. Spoiler alert, plus and minus are going to work just the way you want them to. So is multiplication. The fun part here is division, is where all the weird stuff starts happening. 4 divided by 3, well, that should be 1 1/3. Computer's telling me just 1. Interesting things happening here. I'm going to keep going. I got 1 and 0. Throw that in there. Replace the x value as 1, y is 0. We all know 1 divided by 0 should cause a problem because I'm dividing by 0. Computer tells me -1. Computer doesn't know what to do with that. And keep going. This one, 0 over 1. It's going to give me the answer I actually anticipate this time, is 0. 2 over 8. Throw those in there. Clear. It's also 0. Fascinating. And then, let's see, 8 divided by 2 is 4. Cool, that's what I want to see. So, were all the values what I expected? Not at all. Because if you notice, I only got whole numbers back. Only got integers back, in fact. So, that's quite surprising. What I'm going to do now is it's going to say, hey, let's change all the variable types to double, which means replace all of the int in your code with double. So I'm going to come up here literally, I'm going to type the word double. In this, you'll notice all these things, int, double, void, they're all kind of turning purple. If you're in the actual Arduino IDE, it might turn a different color, but it means they're keywords. And in this case, double is, again, it's a type of variable. It's a type of float variable, in fact, which means floating point decimal number. Double is the most common that people use. That and integer, but of course we're talking now about decimal point numbers. I am going to complete this table. Again, I'm going to just do the very first line and then the division column, because that's where things get fun and interesting. So I'm going to go back to 3 and 4. And I'm going to change this back to addition, because that's what we're starting with. I just typed in 3, typed in 4, fantastic. 7.00, very nice. I got decimals showing up here. Okay, let's do some subtraction. Oh, helps if I actually stop the simulation before trying to type. Once again, you cannot edit code while the program is running. It's -1.00. -1.00. Let's stop the simulation. Multiply. 12.00. So it's still making sense. But it is, since it is a double, it gives me decimal point number. So now if I throw in my division bar, it gives me what I think I should get. I should get 0.75. Doubles decimal point numbers can support decimals. Integers are literally that. They are integers. They cannot support anything. They will all be truncated, which means it's essentially everything is rounded down, or if you just took it and chopped the end off, that is what you get. So let's explore a little further. I'm going to keep it on division bar again. I'm sure you can figure out how to do plus, minus, and multiplication of all the other numbers. Division again once is where it gets interesting. 1.33, fantastic. Math is starting to make sense again. Uh-oh, 1 and 0. Let's see what it thinks. Because this, in the real world, INF. Okay. That's not even a number. And if I keep going, 0.00, 2 and 8. .25, and then my last one, 8 and 2. 4.0. Okay, the world is roses, except for my little friend, INF. So, like in most things, if we divide by 0, weird stuff happens. Weird stuff happens in the Arduino land too. And it's saying, what'd you do? Because that's not something we can do. It's the only thing that's really surprising here. Essentially, if you're doing math and you want decimals, you gotta have a double. Math works like math, division works like division. Integers, math's gonna work like math unless you're dividing, because if you don't have a nice, clear answer that's a whole number at the end, it's gonna get truncated. So let's talk some more cool stuff with variables. And this is where we get into something that'll help us out down the road as we learn more about programming. So what you're going to want to do, erase or comment out any code you're previously using. Mostly, I don't want any of this stuff before. I just want the serial begin, and I'll keep that. Everything else is blank. And we're going to create a variable named a with the integer type with a value of 5. So int a is 5. And then, on the next line, create 2 integer type variables named b and c without giving them a value. And you're going to do that with the following code. So int b, comma, c. So this is so if we want to just initialize a bunch of variables on the same line, they don't have values, we can just kind of use a comma and separate them, that we don't have to just keep typing int over and over again. If I wanted to do it one at a time, I could just do int b and int c. I won't run it like this because it will be like, you already created this variable. You can type it that way as well. I just like to keep things in as few lines as possible. What we're going to do is we're going to create a series of print statements. They're going to display the values of these variables. I'm going to go ahead and copy and paste this code because I don't feel like typing it. And that's what it's there for. It's for you to copy and paste. And I'm going to fix my indentation so it looks all nice and neat. Difference now on a serial monitor, I've used 2 different print statements. I've got serial.print with a string, and then I've got serial.println with a variable. There are a few ways where you can combine variables and strings in one print command, but for most students it's just easier to go ahead and just put multiple lines of serial.print. It makes it a lot easier to just kind of get things running. You don't have to worry about a bunch of weird syntax. It just keeps kind of things moving. And using that code as a guide, we want to create additional print statements for the variables b and c. Well, I have some common sense. This one's got a bunch of a's in it. So I'm going to make one for B. I'm going to change everything over to B. And I'm going to change everything over to C for my next one. And again, I'm going to make these pretty. Doesn't matter to the computer. Matters to me. Now I've got things. Okay, I'm going to run my program. So I'm going to hit that button. Really interesting. Okay, so A is 5. Which is what I told it to be. B and C we just created and we didn't give a value. So what happens in programming is it's just like, it's going to give it a garbage value, which in this case is negative 31,488 and negative 31,744. These values, that is not negative, don't really mean anything. But the thing is, if you were to try and use B and C like I did, and then if you tried to use them in some sort of math, you're going to get some really unexpected results. So they pick up some garbage values. First, we're going to add some values to B. And what I'm going to do is, once I stop this, is I'm going to copy all of these, and we're going to add these. So we're going to set b to be equal to 1 more than the value of a. So I'm just going to type b equals a plus 1. Now you notice I did not use int. If I used int again, it should yell at me because it's saying, hey, redeclaration of integer b. You only need to declare a variable and create it once. Anything after that, you can just type it. And it won't let you do that, in fact, as you noticed. So get rid of that. B is equal to the value of a plus 1. And what I'm going to do, because if you look ahead in the document, you're going to start creating a chart of everything, and I'm just going to have it go ahead and display everything for me. In fact, what I'm going to even do is I can print a blank serial.println statement, and that'll just give me some line spacing in my serial monitor. It makes everything a little easier to read. So I've got all of those. Record the values displayed by the serial monitor. Let's go ahead and clear them so I know what I'm looking at is just what I ran. So everything kind of makes sense. So the first ones didn't change, which is good because I would hope they didn't. It's gonna, you'll notice it'll pick up the same garbage values every time. And then after I ran b equals a plus 1, a is still 5, b is 6, 5 plus 1 is 6, hope so. And I didn't do anything with c, so it's still got the same garbage value. I'm going to keep changing things with b. I am going to come back, stop my program. Now I'm going to say, hey b, I actually want you to be a plus plus, which means something. We'll figure that out. So b equals a plus plus, semicolon, because I got to end that as always. I think I already have these in my clipboard, but I'll copy them anyway. What it's going to do is just going to tell me A, B, and C again. So I'll clear everything out, and I'm going to run it. So the first two are the same, and now, interestingly enough, something odd happens. Maybe not what I was expecting. Maybe it was. Maybe you've seen programming before, and you know what I'm doing, and you know all the secrets. If you were in my class, I would tell you no spoilers, please. I am not good at hitting the minus button. Now we're at A is now 6. And then B is 5. Negative 8,000. There we go. And I got one more thing that I want to do. So I'm going to come down here. When it says what I want to do, I want to say, hey C, I'm going to finally give you a value. This time we're going to use plus plus A. And then I'm going to put all of my prints in there again. Clear everything out. Kind of the purpose of this exercise is just a little bit of exploration. You and students may not know exactly what is going on at this point. You're just kind of pushing buttons and seeing what happens. It's kind of the whole point. So I'm going to fill my chart out again. Oh, this keyboard's different. That's why. I know what's going on. So on the second one, A was 5, B was 6. Still didn't have assigned a value for C yet. And the last time we had 6, 5, and then 31, and 4, 4. And this last time, A is now 7, B is 5, and C is 7. Well, that is really something interesting. And kind of the point of this section of the activities to kind of get students thinking of where you would be going after that is you're going to delve a lot more into what this plus plus means. And I'll give you a brief understanding here, just in case if you don't want to go on and do any of the, it's part of my, the 8th grade activity. If you don't go on to that, I'll give you the brief explanation. If you want to keep going on to that, you know, if you want to find out on your own, pause me and go on to that. Otherwise, I will give you all the spoilers. What does plus plus do? It increases the value of the variable that it's associated with. So what happens is, and I will just sort of type it here in the code, that if I do A++, it is the same thing as typing A is equal to A plus 1. They do the exact same thing, and whether or not that plus plus happens before or after the A changes what gets passed on to another variable. Because if you notice, I used B is equal to A++, and B was assigned the value of 5. But when I told C is equal to plus plus A, C got the value of 7. So what happened is on line 25, I used B equals A++. It's like, okay, well, B is equal to A, because that actually happens first. And then the value of A is increased, and that actually gets stored to the value of A. And then C, what happens if it's plus plus A, that happens first. So it gets the value of 7, because if you recall, line 25 happened, A became 6. So now it's sitting in here as 6, becomes 7, then it gets passed to C. There's some fun rules as to which one happens first and which one happens second. And the scope of this task 2, that doesn't matter. It's just, again, we're pushing buttons and seeing what happens in these activities. Later on, we're going to start using those. What's really common is generally variable followed by, in this case, it's called an increment, because we're incrementing our variable by 1 each time. And that's typically a little more common is to see it that way. But you just have to be really careful because you can actually put it both ways and you get very different results based on what you're doing. And if I had wanted B to be 6, I should not have wrote it like this, because in this case, obviously, it's 5. That's what I recorded. And of course, the last question to ask and have kids think about is it a good idea to have all variables starting out with a value? Generally speaking, the answer is probably yes, even if you put in a dummy value. At least then it's a dummy value that you control instead of whatever the Arduino decides to make. Because if I said, okay, B and C, you're just going to be 0 until I'm ready, at least I know that value is 0. I don't know that it's going to be negative 31,488 or negative 31,744. That's something kind of outside of my control that I don't know. And that's what makes a big difference. So this is kind of the end of the activity for the 6th and 7th grade sort of computer science professional development. Again, you are welcome to explore in the folder where you found these documents. There's all the ones for the 8th grade and just a few more as well, though there aren't videos for everyone. There are ones for the 8th grade activities, and just sort of see where we'd be going here and what you can all do with Arduinos.